Hello again, grade 8s. In today's lesson, we are going to look at an alternate way that we can actually calculate the probability of independent events. Again, the emphasis is going to be to try to do this without going through like the more tedious process of drawing tree diagrams and tables. So once again, it's going to be an alternate method of doing something we're already a little bit familiar with. So far, we have used tables and tree diagrams to determine the probability of multiple independent events occurring. Again, although this process is effective, constructing diagrams is tedious if there are a large number of possible outcomes. And again, we experienced a little bit of that tedium in the previous lesson where we had to draw that tree diagram for three different independent events occurring. It turns out there's also a way you can calculate the probability of independent events by using multiplication. So if I want to calculate the probability of multiple independent events occurring, this can be determined by multiplying the probabilities for each single event together. For example, if we had two events, the probability of event A occurring and then B occurring, we could actually calculate by taking the probability of event A and multiplying by the probability of event B. Or if we had three independent events, the probability of events A, B, and C occurring could be determined by taking the probability of event A occurring, multiplying by the probability of event B occurring, and multiplying by the probability of event C occurring. And again, the key thing here is that I can actually do these calculations prior to even constructing a table or a tree diagram, which can potentially save me a lot of work in performing these calculations. So let's show you how to do this. So first example, it says a 6-sided die and a 4-sided die are rolled, as shown in the diagram below. A, write the sample space for each object separately. So we'll start off by doing that. Okay, so we're in part A. Okay, so my 6-sided die would be event 1. It says write the sample space. The sample space is just write the outcomes for that event, separated by in brackets, separated by commas. So for a 6-sided die, my possible outcomes would be you could roll a 1, you could roll a 2, you could roll a 3, you could roll a 4, you could roll a 5, or you could roll a 6. Okay, that's my sample space for just the 6-sided die. So again, I'm doing the sample space for each object separately, not the combination of the two of them. Your 4-sided die would only have a sample space with 4 outcomes. You could roll 1, you could roll 2, you could roll 3, or you could roll a 4. Okay, those are my different outcomes for that. Okay, B, it says calculate the probability of obtaining the number 4 on both dice. Okay, now notice that we haven't been asked to do a tree diagram or a table first, which normally we would do prior to doing a probability calculation, but we're actually going to avoid doing this by using this alternate method. Okay, so let's start off with B here. So the first one wants us to calculate the probability of obtaining the number 4 on both of these dice. Now, according to my equation, that would be equal to the probability of rolling a 4 on the 6-sided die times the probability of rolling a 4 on the 6-sided die times the probability of rolling a 4 on the 4-sided die. So again, just to distinguish this here, so this would be on the 6-sided die. And this would be on the four-sided die. Okay, so again, that's what my equation tells me. The probability of event A and B occurring can be calculated by taking the probability of event A multiplied by the probability of event B. So that's what I'm doing here. I'm separating them. Okay, let's try to calculate this. So this would be like favorable outcomes over possible outcomes. Now I'm just going to abbreviate this a bit by not showing the actual equation. Okay, so let's look at this. So what's the probability of obtaining a 4 on the six-sided die? Well, if you look at the six-sided die, there's 6 possible outcomes, and there's only one way that you can obtain a 4, which is this one. So that would be 1 over 6. That's multiplied by the probability of obtaining a 4 on the four-sided die. So on the four-sided die, the total number of possible outcomes would be 1, 2, 3, 4. And there's only one outcome that's favorable for a 4. Therefore, you'd have 1 over 4. So to calculate this, well, we dealt with the multiplication of fractions in the previous unit. So this would be equal to numerator times numerator would be 1 times 1, which is 1, divided by denominator times denominator. 6 times 4 would be 24. Turn that into a decimal. So as a decimal, this would give you a repeating decimal number, 0.041666, etc. And again, the way we want to round this, if it's a repeating decimal, is we want to go to the nearest thousandth. So nearest thousandth means the first 3 decimal places, so 0, 4, and 1. And then to determine how to round that, we have to look at what the value of the fourth decimal is. The fourth decimal has a value of 6, so that's going to cause that decimal, that's going to cause the thousands digit to round it from a 1 to a 2. So then this would turn into 0.042. Then we take that decimal spot and move it 2 units to the right. So 1 over here, 1 over there. It would actually give you 4.2%, not 42%, because you have that extra 0 in front of there. Okay, calculate the probability of obtaining less than a 4 on both dice. Okay, so let's go to just have more space over here. Okay, so the probability of less than a 4 on the first dice and less than a 4 on the second one. Now, according to my equation right here, so again, the probability of 2 independent events occurring would be equal to the probability of event A occurring multiplied by the probability of event B occurring. Okay, so I can break this down to the probability of obtaining less than a 4 on the six-sided die multiplied by the probability of obtaining less than a 4 on the four-sided die. Okay, so let's go back to the previous page and identify. So let's set up the fraction first, actually. Okay, so it's favorable outcomes over possible outcomes. So for the six-sided die, you have 6 possible outcomes multiplied by, for the four-sided die, you have 4 possible outcomes. So we need to figure out the number of favorable outcomes are for each die. Okay, so let's go here. Okay, so we want less than 4. So less than 4 would be a number that is smaller than 4, but not including 4. So on the six-sided die, there's 1, 2, 3 possible ways that you can obtain that. Okay, so let's go back to this slide and we'll fill that fraction in. 3 favorable ways in the six-sided die to get a number that's less than 4. And if we go back here, how many ways can we get a number that's less than 4 on the four-sided die? Well, it's also going to be 3, because you can obtain this one, you can obtain that one, or you can obtain this one right here. Okay. So then we go back to this, and then do that calculation. So that would be 3 over 4. Okay, Okay, numerator times numerator. 3 times 3 would be 9. And then 6 times 4 would be 24. And then that looks like a 9 there. Let's fix that so it looks better. That is a 4, or it should be a 4. There we go. 9 over 24. Okay, yes, this is a 9 on the top. Okay, 9 over 24 would give you a nice terminating decimal. So give you 0.375. And then multiply by 100 and move the decimal spot 2 units to the right, and you get 37.5%. Okay, so it's calculate the probability of obtaining a 4 on the 6-sided die and less than a 4 on the 4-sided die. Okay, so let's set up our probability equation. So the probability of obtaining a 4 on the 6-sided die and less than a 4 on the 4-sided die. And again, this would be equal to, if you look at your equation, the probability of 2 independent events occurring, probability of event A, then B occurring, is a probability of event A occurring multiplied by the probability of event B occurring. So this would be the probability of obtaining exactly a 4 on the 6-sided die multiplied by the probability of obtaining less than a 4 on the 4-sided die. Okay, so this is going to be favorable outcomes over possible outcomes. So on the 6-sided die, there's 6 possible outcomes. And how many ways can you obtain a 4 on the 6-sided die? Exactly a 4? Just one way. So the probability of obtaining a 4 on the 6-sided die is 1 over 6. We're going to multiply that by the probability of obtaining less than a 4 on the 4-sided die. So on the 4-sided die, there's 4 possible outcomes. And the number of ways we can obtain a number that's less than 4 would be 1, 2, 3 on that die. So this would be 1 over 6 times 3 over 4. 1 times 3 is 3. And then 6 times 4 would be 24. And if we turn that into a decimal, it's also a nice terminating decimal. So we get 0.125. Multiply by 100 to turn it into a percentage, and you get 12.5%. Again, we did all these calculations without even drawing a table or a tree diagram. Now, part C wants us to confirm this. So it says C, confirm the results from B by constructing a table and then calculating probabilities using the table. Okay, so we're just going to prove this method we used here is actually going to be true. Okay, so for my table, you write event number 1 is going to be your rows. So that's going to be the 6-sided die. And on the 6-sided die, you have events 1, where you can roll a 1, 2, 3, 4, 5, or a 6. Okay, on the 4-sided die, you can roll a 1, you can roll a 2, you can roll a 3, you can roll a 4. Okay, well, let's do some lines just to show that it is a table. Let's do a horizontal line here and a vertical line right there, and that's probably good enough. Okay. You could make a table fancier if you wanted to, but this is fine. Okay, so let's match up the rows and columns to identify all the different outcomes. So we'd have 1, 1. We'd have 1, 2, 1, 3, 1, 4. We'd have 2, 1, 2, 2, 2, 3, 2, 4, 3, 1, 3, 2, 3, 3, 3, 4, 4, 1, 4, 2, 4, 3, 4, 4, 5, 1, 5, 2, 5, 3, 5, 4. Isn't this tedious? 6, 1, 6, 2, 6, 3, 6, 4. Okay, there's my table. Okay, now it says we're going to use the table just to confirm that we did these probability calculations correct. Okay, so maybe I'll just show the probability calculations to the side. I'm not going to do a complete set of probability calculations. I'm just going to show that the fractions match up. Okay, so the first one was, what was the probability of obtaining a 4 on both die? Okay, so the probability of obtaining a 4 on both die would be equal to the number of favorable outcomes divided by the number of possible outcomes. Now, if you look at the table here, so first of all, how many entries are there in the table? Well, there's 24 of them. Okay, and then how many ways can you get a 4, exactly a 4 on both those die? Well, if you look at the table here, there's only one way. Okay, it's going to be this entry specifically right here. Okay, so that would be 1 over 24. Okay, let's see if that was the same number we got previously. Okay, so the probability of obtaining a 4 on each die is 1 over 24. And if you go back to the previous slide, when we did our multiplication method, the probability of obtaining a 4 on each die was also 1 over 24. So this method does work. You can take the probability of each independent event occurring and multiply them by each other to get the probability of both events occurring. Okay, well, how about the other ones? Okay, we're just going to confirm all three of them. Okay, so the probability of obtaining less than 4 on each die would be equal to the number of favorable outcomes over the number of possible outcomes. How many possible outcomes? There's 24 on the table. And now let's look at all the different table entries that would have numbers on each die that are less than 4. Okay, so that would be 1, 1, 1, 2, 1, 3. That would be 2, 1, 2, 2, 2, 3, 3, 1, 3, 2, 3, 3. Basically, if we need to have less than 4 on each die, we cannot have any combination that has a number that's 4 or bigger. So the rest of the table would not fall into that correct category. Okay, so how many of these actually gave me an outcome where I had less than a 4 on each die? Well, that was 9 out of 24. Okay, so let's fill that in. So 9 out of 24. And how does that compare to our calculation using the multiplication method? So probability of obtaining less than a 4 on each die would be 9 over 24. And with my multiplication method, whoops, up here. Let's erase that. That wasn't the correct one. Yeah. Okay, the probability of getting less than a 4 on each die was also 9 out of 24. Okay, I'm sure you'd agree that doing the multiplication method is much faster than drawing this horrible table and then doing the probability calculations. So it's an alternate method to doing it quicker. Okay, let's confirm the last one. So the last one was, what's the probability of obtaining a 4, exactly a 4 on the 6-sided die, and less than a 4 on the 4-sided die? So that would be your favorable outcomes. There are possible outcomes. 24 possible outcomes. And how many ways can you get exactly a 4 on the 6-sided die and less than a 4 on the 4-sided die? So we're going to focus on this row in the table here, because this row in the table is going to be exactly a 4 on the 6-sided die. So which ones would be okay? 4 and 1. Yeah, exactly a 4, less than 4 on the 4-sided die. 2 is less than a 4 on the 4-sided die. And then 3 is less than a 4 on the 4-sided die. There's actually only 3 ways you can get that. So this would then be 3 over 24. And then let's compare now. The probability of obtaining less a 4 on the six-sided die and less than a 4 on the four-sided die is 3 over 24. And comparing that to my multiplication method, you got the exact same thing. So for each of these, you can do the calculations in two ways. You can either draw a table or tree diagram and then do your probability calculation, which takes a long time because sometimes the tree diagram and the tables are really big to draw, or you can use the multiplication method. The multiplication method is much, much quicker. Okay, let's look at one more. So this actually was the example from the previous lesson. That's the one where we had like that really, really awful tree diagram. And actually, I just took a scanned picture of my work, and I just pasted it into the PowerPoint here. So you can see like what that looks like when you have three independent events. The tree diagram gets really, really out of control very, very quickly. Like it fills up quite a bit of the space. Okay, so it says, let's try to do that same probability calculation, except we're going to do it just with multiplication. We're not going to actually, we're not going to do the tree diagram method. Okay, so it says A, write the sample space for each object separately. Okay, so let's do that up here. Oops. Sorry, there's these buttons at the top of my tablet that my fingers keep accidentally hitting whenever I go to the top of a page and write something. Not that you actually care about why that's appearing, but I would just thought I'd tell you anyways. Okay, so we want the sample space for each one of these objects. Okay, so we have the coin. Okay, so my sample space for the coin would be you can get heads or you can get tails. Again, sample space is write the outcome in brackets and then separate it with a comma. The spinner, we can obtain an A, we can obtain a B, or we can obtain C. And the die, my sample space would be we could roll a 1, we could roll a 2, we could roll a 3, and we could roll a 4. Okay, now, B says, calculate the probability of flipping tails, spinning a consonant, and rolling at least a 2. We actually did that exact calculation in the previous lesson. Okay, so, but we're going to do the multiplication method this time. So the probability of flipping tails, spinning a consonant, and obtaining at least a 3. So at least a 3 means greater, did I say 3? 2, at least a 2, greater than or equal to 2. Now, if we go back to the equation, for 3 independent events, the probability of event A, B, and C occurring would be equal to the probability of event A occurring, multiplied by the probability of event B occurring, multiplied by the probability of event C occurring. So let's break it down using that equation here. So this would be equal to the probability of obtaining tails, a constant, and greater than or equal to 2 would be the probability of obtaining tails on the coin, multiplied by the probability of obtaining a consonant on the spinner, multiplied by the probability of obtaining a number that is greater than or equal to 2 on the die. Okay. Again, the idea right here is we're going to do this without even using a tree diagram. Okay, so this would be equal to, okay, so let's deal with this one first, the probability of obtaining tails on the coin. Okay, so favorable outcomes over possible outcomes. There's 2 possible outcomes for the coin, either get heads or tails. Obtaining tails, there's only one way you can get that, okay? So that'd be 1 over 2. Okay, multiply by the probability of getting a consonant on the spinner. Okay, so on the spinner, there are 3 possible outcomes. And how many consonants are there? There's B and there's C. So there's 2 consonants, 2 favorable outcomes. and then multiply by the probability of getting greater than or equal to 2 on the die. Well, on the die, there's 4 possible outcomes, and the numbers that be greater than or equal to 2 would be 2, 3, and 4. Okay, so we're going to go 1 over 2 times 2 over 3 times 3 over 4. Okay, so you could just go numerator times numerator times numerator. In fact, that's what I'll just do here. So 1 times 2 is 2. 2 times 3 is going to be 6. Then denominator times denominator times denominator. So denominator times denominator would be 2 times 3, which is 6. And then 6 times the other denominator of 4 would be 24. Okay, so we have 6 over 24. And then if we go ahead and we calculate this, this would be equal to 0.25. Turn it into a percentage, and then it would be 25%. Now, we did all of that without drawing this horrible tree diagram here. So the multiplication method is useful in avoiding, the tedium of constructing these tables and tree diagrams. Now, we could use the tree diagram here just to confirm that that is correct. So if we look at the tree diagram, so tails, consonant, and a number that is greater than or equal to 2. So if we calculate it the other way, it'd be the probability of getting tails, consonant, and then greater than or equal to 2 would be our favorable outcomes over the possible outcomes. How many branches on the tree? There's 24 of them. And how many ways can you get tails, a constant, and greater than or equal to 2? It'd be 6 over 24. And then if you just simply quickly compare, okay, so probability of tails, constant, greater than or equal to 2 is 6 over 24. Using the multiplication method, probability of tails, constant, greater than or equal to 2 is also 6 over 24. Except up here, I wouldn't have needed to do the tree diagram to actually determine that probability. So again, we're using our knowledge of fraction multiplication to actually do this calculation much, much quicker. Okay, so it's just an alternate way to calculate probability of independent events, saving you, again, just the time required to construct a large table or a large tree diagram. Okay, so that's it for this lesson. And what you can do is in the probability work booklet, you can complete the assignment called Calculating Probability by Multiplication. And then I will talk to you in the next lesson, which is the last lesson for the unit on probability. Talk to you then.